Hello everyone and welcome to our team presentation. Today I will introduce you to OmniSynth. It is a photorealistic synthetic data pipeline. It has automated annotations for object detection. It is built completely on Blender 4.2 and Python. It's capable of generating 50 images in under 2 minutes. It is capable of generating over 2,000 images in a single line of command. And over on the right here, you will see a sneak peek of our result. RGB images of high resolution, of high quality, annotated mask, and JSON label to support machine learning training. So a bit about why we use synthetic data. A big problem in machine learning is to procure big and quality data. So we generate them synthetically to save money, time, and effort. Today, KV presented us with a challenge to create a pipeline that can make RGB images together with masks and the annotation specifically for object detection. They provided us with the core objectives along with the stretch goals. And in this presentation, I will show you how we were able to meet all of these objectives along with stretch goals and further beyond. So a bit about our overall architecture. First, we acquire the asset. You give us the file with the model and the texture, and we import it into our scene. Within this scene, we populate it with camera, light, backgrounds, occluders, and then we multiply your target objects for domain randomization. Our randomizer tool supports a wide range of customizability. You can randomize your camera, your light, the objects themselves, the background, everything. And then our next step is rendering. We provide configs for rendering, or we have a pre-built supported settings in our configs. It is able to render RGB images along with the annotated mask. And then we extract those masks into a KV structured label or a popular COCO structure. So during our design process, we made certain optimization decisions. First is using a pool-based strategy. So instead of re-rendering multiple images multiple times during our rendering process, we pre-render everything at the beginning. Pre-spawn everything at the beginning, and then we toggle hide rendering or not throughout the process. We also make a decision about our compositor masking. Instead of using a built-in support with EXR, we use a KV provided example with ID mask nodes. This approach is a lot simpler and more fitting to our use case. We also support seeded RNG, allowing fully deterministic randomization. This is to support reproducibility within our datasets. Each of our scenes allow 6 axes of independent randomization. Of course, we allow you to randomize your camera, your light, and each of the objects. You can randomize their positions, their rotation, and our objects also support collision detection to help avoid mesh clipping. Our background has randomization in texture, roughness. Our distractor, we have built-in Blender primitive shapes. And last but not least, our group assignment. We were able to group certain target objects together into grid sizes 1 by 1, 2 by 2, 3 by 3. And the whole group were able to move as a rigid unit in positions and in rotation. Beyond the core objectives, we went further and beyond and met the stretch goal. We were able to annotate the labels in either YAML or JSON format. We were able to generate instance segmentation masks. and then we were able to import custom 3D objects beyond the provided asset. We were able to generate over 2,000 images, and then we were able to train an object detection model with it. Even beyond that, we optimized the generation process down to less than a second per image. We were able to accomplish this using a low resolution rendering and a low cycle sampling, but we did not sacrifice any kind of quality in a object detection training task. 640 by 640 resolution was within acceptable range for a YOLO V8 detection model, and we coupled our low sampling cycle with an image denoiser to not lose out too much on quality. Along with our pool-based strategy, we were able to really optimize our processing time. We also support multi-GPU rendering. Each GPU added will significantly reduce our rendering time. And of course, we support full customizability with our rendering config. And of course, we built this tool for engineers and allow even further customizability. You are able to override most of the most important tasks like randomizers. You can even have custom renderer and custom annotation. To add your own custom dataset, you only need to paste your file into a pre-existing folder and then add a few lines into our config option. That brings us to the end of this presentation. Thank you for listening.